have here my late 60s souped up Con 10M. This is a Slant Link 5-star fiber cell 3.5 stock 2-screw ligature. This is a modern Babbitt Link tone edge 5-star with a fiber cell 3.5 reed stock ligature. Okay, this is the modern Babbitt Link 5-star again. This time I have a temporary baffle inside, just a quickie thing that I put in there to try to get it a little closer without doing any facing work on it. It still sounds a little stuffy to me, but it's probably closer. Okay, same modern Babbitt Link with the temporary baffle in it. This time I pulled the reed away from the tip a little bit to simulate a thinner tip rail, which is on the slant. So let's see. It's about a 32nd of an inch back from the tip rail. Gets a little blurry up close, but. And this is the amount of temporary, baffle material I put inside this. I tried to get it closer to the shape of the slant. I'll pull the material out now and show you how big of a ball that makes. This is just mounting putty or poster hanging putty. Thickness, I've tried to get the thickness at the thickest part, about 60 thousandths. That's probably close to what won't fit in there, so some parts might have been over that, some might be less. If I roll that up in a ball, get an idea how much material I used. So it's bigger than a 1/4 of an inch, probably 5/16 to 3/8. $400 thousandths, so a little over. Okay, here we have the two mouthpieces, two links side by side, the Slant signature Otto Link and the modern Babbitt Otto Link. This one has a USA. It says 5-star on the heel here, whereas the Slant has it on the table, 5-star. This one doesn't look modified to me. And it hasn't been played that much, so it's a pretty good example of a Slant signature. And you can just tell by the marks across the table. They go across, which is from a facing machine, I believe, instead of longitudinally from a hand finishing. Though this one shows kind of longitudinal, but they're not the same as sandpaper marks. Some of the major differences. There's a slight difference in the body length. The overall length is about the same, 4 inches. This has a slightly longer body here and then a shorter shank to make up the difference. The facing is different on both. I'll highlight that. Tip opening's similar. They're both around 81 to 83, something like that. But the modern Link, and it depends on which one of the modern ones you get, they're more inconsistent. This one has a fairly wide tip rail compared to the Slant, probably 3 times the width of it. And the window's a little shorter. You can see that there. The biggest difference for playing, I believe, is the baffle, which Slant Link has a slightly higher baffle. It's as much as 60 thousandths, which is a 1/16 of an inch higher here than here. They both have a similar wall here. I thought I've seen some of these undercut, but maybe that was an after modification. This one happens to have a flatter facing curve in this area. If you played 5 of these, they'd probably all be different. What else? Well, the baffle, besides being higher, I mean, since this is the modern Link, it actually rolls over and then it's actually concave or flat in this area, and it just makes it sound stuffier, not quite as brilliant. There's a slight difference in the width inside the throat chamber area of here. The Slant has a little more material, a little smaller bore, but not by tons. So it's only about 10 thousandths difference inside there. But the baffle shapes, let me show you with on my PC the difference in that. So let me try to get your bearings here. What I have is the mouthpiece is measured. I took readings from the bottom of the table up into the mouthpiece. I actually did them like this with this gauge, different areas, different lengths into the mouthpiece. So, what you're looking at here is a plot of my measurements. Is the blue line for this modern Link. You can see it shows the rollover shape that I mentioned, then the concavity in this area, and the magenta line underneath is the Slant. Okay, see they have a similar tip opening, about 81, 83 thousandths, but up in this area there's, like I said, 60 thousandths difference between these two lines here, and then further here, this is the last reading at the the edge of the window at the bottom here. There's a difference there. Let me show you how to make this measurement. Jim Romaine turned me on to this, and I think it's a good way to go. If you take a set of calipers, digital calipers, you can use these 3 ways. You can take outside measurements, you can take inside measurements, and there's also a probe on the end. And this is what we're using here. So make sure you're zeroed, and then hold your mouthpiece like so, and you try to get it square. There's not much surface area there on the end, but you can kind of feel it. Once you get the gauge square, lower the probe down in there until it hits bottom, and then take a look at that reading. Okay, that reading is 0.628 on the Slant. We go over to the Babbitt. That same reading, I get 0.639. So it's another 10 thousandths. Now, Normally Babbitts, I believe, run higher than that. Let me double check this reading. They get more like 65, 650 thousandths. So that's 648. So maybe I had it tilted or something. That one's 640. That's more typical of what I see. Observations that Jim made is that the great early Babbitts and Slants tend to have a measurement that's between like 580,000 and 600,000. That's 0.58 and 0.6. Good ones tend to be between 0.6 and 6.2, and the tubby ones tend to have a 0.65 measurement in this area. And as you can see from my plot on the computer, that's just one measurement. It's not because of that one measurement over here that we're having all the problem. It's from all this, the entire baffle. So 20 thousandths difference up here isn't that big of a deal, but 60 thousandths throughout all here, that's a big deal. I went back and thought about this plot some more of the baffle shape comparison, and I made a correction back here. What I didn't do properly on the previous plot was account for the differences in window length. The Slant Link has a window length that's 44 millimeters, and the Babbitt Modern Link has 41.5 millimeters. And I had previously plotted them as being the same, and when these 2 points line up, there was only a 20 thousandths difference. But when you plot them at their proper distance away from the tip, that floor measurement would have been similar to all the other measurements I did along the baffle. It's 55 or 60 thousandths different there. So you need to take that into account when you make your readings. And sometimes refacers can make a window longer, so that'll change where your point your measurement is taken at. The way I take this measurement is I use this custom-made gauge. It's a standard dial gauge. It has a pointed probe on it. You can purchase something like that, but I had a friend of mine made up the bracketry here for this. You can purchase gauges similar to this. They're zeroed, here at the table. This can be used to measure tip opening. You have to take the spring tension off. Let me turn on a light here. Okay, like so. You go inside the tip rail. You can measure the middle of the tip rail, the end if you want to. I use the inside of the tip rail as a standard. Now, what I do for all the other points of the baffle is I have scratched on the edge of this gauge file markings at 3, let's see if I can get it memory, 3, 7, 12, 18, and 25 millimeters. And those are my data points here. So after I take the tip opening measurement, I have a dot that I put on the mouthpiece. I zero the gauge right at the tip of the mouthpiece, and then where my first file mark is, I put a little white dot on the mouthpiece. Then I drop down to my next file mark, which is the 3 millimeter from that 0 point. I take a reading. Then I drop down to the next one. So I have this predetermined, they're closer together near the tip because usually a lot more is happening with baffle shapes near the tip. So that's why I could take them equally spaced, it's just more data. So I do this until I get all the way down to 25 millimeter right there. You can go farther, but that captures most of what I'm interested in. But as you can see in this case, adding one more point for the drop at the end of the window gives you a pretty good data set for the shape of that baffle. And again, that's in this orientation. So that's what you're looking at, the distance from the table up to the baffle.